Okay, welcome to another lecture. Today I'm still your physics teacher, Mr. Moses. Welcome to class. In the last class, we talked about mechanical energy and how it is converted from potential to kinetic energy, how it is not lost. In this class, we talk about machines, and as you can see there, we have that machine is a tool that allows a force applied at one point to overcome a resisting force at another point. In other words, machines we know that they are tools made to make our work easier. So the way the machine is actually designed is such that a little effort is used to overcome a large load. That's the reason why the machine was designed. So that with little effort we can overcome large loads. With little effort we can do much work. That's why it is said that the machine makes work easier. So little effort applied at one point will overcome a large load at another point. Here we have some examples of machines. We have the lever, the pulley, the wheelbarrow, the nutcracker, the inclined plane. We have some pictures here. The first one there with the man pushing a load down is the lever, and then we have the pulley system. As you can see, we have the wedge. The one with the wood is the wedge. So there are actually different kinds of machine, both small and big. All of them are made to make work easier by applying a very small effort. And then we have mechanical advantage. Mechanical advantage is the ability of a machine to overcome a large load through a small effort. That means that if a machine has the ability of overcoming very big load or a large resisting force with very little effort, it has a very good or high mechanical advantage. But if it overcomes a large load with so much effort, it means it has a low mechanical advantage. Mathematically, mechanical advantage is represented as load over effort, and it has no unit because load is in Newton, effort is in Newton. So if we are dividing the two of them, then Newton will cancel out. And then we also have velocity ratio. It's defined as the ratio of the distance moved by the effort to the distance moved by the load. The distance moved by the effort to the distance moved by the load. Mathematically, it is represented as distance moved by effort over distance moved by the load. When we say distance moved by effort, it means when you apply an effort to a particular point, taking a lever for instance, the distance that the effort will travel until it gets to the center of the load, where we refer to as the center of the machine, where we refer to as the fulcrum, is the distance moved by effort. And then the distance moved by the load is the meters moved by the load until it gets to the center of the machine, which is the fulcrum. And then we have the efficiency of a machine. The efficiency of a machine is a number that measures the effectiveness of a machine in transforming power input into the machine to power output. That means how well can your machine convert the effort you are putting into it to produce an output that is efficient, that is effective. That's what we mean by efficiency. It's measured in percentage. That means if I put work into a machine, if I put effort into a machine, how much productiveness will it give? How much effective result will it give? That's what we mean by the efficiency of a machine. It's also related to mechanical advantage, and it is mathematically represented as the power output over the power input. is equal to 1. We can also say that it is mechanical advantage over velocity ratio times 100%. It therefore means that efficiency is talking about if I put small effort into a machine, how much useful work will it do? That's what it means. And here we have types of machine. The first one there is the lever. The lever has the load, the effort, and then the fulcrum. And then we have the wheel and axle, the one at the center. The wheel is the round thing that looks like tire, and the axle is the bowl joining them together. We also have the inclined plane, and then we have the wedge. Different types of machines. We have the gear wheels, as you can see on the picture, and then we have the screw jack. The screw jack is the one on the extreme right. There are different types of machines that are put together to form a whole system. And then we have examples of machines. We have examples and calculations in machines. Calculate the mechanical advantage of a machine which lifts a load of 500 newton with an applied effort of 15 newton. We have that mechanical advantage load over effort, and so we have 500 or 600 over the efforts. We also have that example 2, if the distance moved by a load is 10 meters and the distance moved by a corresponding effort is 4 meters, calculate the velocity ratio of the machine. Hence we have the load moved by the distance moved by effort over the distance moved by load. And then we also have, if a machine has a velocity ratio of 10 and a mechanical advantage of 4, calculate the efficiency of the machine. We said earlier that efficiency is mechanical advantage over velocity ratio times 100. Hence we have 4 over 10 times 100, which is 40. Please try out the leading questions before the video. Thank you very much. I'll see you in the next class. Goodbye.